All right, perfect. Thanks for confirmation. So we start Zero to SD WAN today. Welcome to Zero to SD WAN. And this course is going to be 8 weeks. And there might be few more weeks added depending on if you need more practice or if we have more labs. So it is going to be very in-depth. So let's see exactly what is the course structure, what are we going to cover, and what exam can you take after this, and then the basic idea about EVNG setup as well, like what exactly will we have into EVNG that we'll use, right? So let's talk about the course structure first. So it is going to be once a week. So we are going to have it every Monday morning Bangkok time, or I think it is Sunday evening there back in US. It will be 1.5 to 2 hours session per session. 8 weeks course, but it could be 8+ weeks. So it's like there might be some bonus weeks at the end, depending on if we have a few more labs or if we need to discuss a few more topics in detail. So we can actually be flexible beyond 8 weeks. It's in-depth theory course plus the practical. So the theory is important. Of course, we need to make sure we understand how SD-WAN works, what is SD-WAN, how Cisco approaches it, and then how we can actually implement all the different aspects of it. So we will have in-depth theory followed by practicals in the labs, just like we do into our other courses as well. Multiple practical labs will be there. So the practical labs that we are going to do, they are completely be based on the theory that we are going to cover before that. So we will make sure that we understand the concept first. We understand how the particular flow, the particular practical flow will go, and then we will do the labs. So of course, I will also do the lab into the course itself or into the session itself. And then in this particular course, you don't need to do the lab at the same time. So you will have 1 week. For example, in the session, I will explain the theory that needs to be explained. Maybe it will be a completely theory session. Then next week we will do the lab, and then you can follow the lab, or you can do the same lab during the week. So you will have ample time to do it. And if you have any questions or any issues, we will have a whole week to make sure that we can fix it, or we can find out the issues and fix them, right? So how the labs will work is that the labs PDF will be sent to you after the session. So if we have a lab week where we are going to do the configuration, or if I will be showing you the configuration, then after that, I'll send you the labs PDF where there will be instruction how to do it. And on the EVNG, we will have the topology. So you can open the topology and you can configure it according to the requirement. In this case, the solution will not be provided to you immediately, so that you can actually at least try it first. And lab solution file will be sent to you later in the same week. So you will have few days, couple of days without the solution, and then of course I'll send you the solution file as well, so that you can compare how exactly it needs to be done. And of course you might have done it slightly differently, so you can also compare it if there are multiple ways to do it, or if there is something that needs to be discussed more, that why something has to be done, or a certain part of the lab is done in a certain way. So we can actually compare that part as well, right? And of course, it needs no previous knowledge of SD-WAN for this course structure. So we will actually be taking it from the scratch, understanding all the aspects of SD-WAN. So if you have never done Cisco SD-WAN before, it will be completely fine. Or if you already have some knowledge of SD-WAN, that is also good, because it will just bridge the gap, or fill the gaps if you have any issues into the different parts, right? So that's why it is grounds up course and covers everything that we need to cover for Cisco SD-WAN, right? Now, what tools are we going to use for this? So just like our other courses, we use EVNG on VMware. So this is the recommended way. So if you have a Windows system, that is recommended to have Microsoft Windows, and EVNG installed on a VMware player or VMware workstation, if you have that, right? Now, topologies are already set in EVNG. So I will be sharing an OVA file, which you can simply import into VMware, and a pre-setup EVNG will already be there. Now, pre-setup means that you will see that for Cisco SD-WAN, there are some certain images that you need to upload to EVNG, and these are CAMU images. Q emulator images, and these images need some previous setup so that they can show up into EVE-NG and you can start using them into different topologies, right? So that part is already done, so that you don't need to look for images and copy them into EVE-NG and set up the things that you need to set up. So that part is already done for you into the OVA. So you just need to import the OVA and you are ready to go. You can start practicing, start practicals on SD-WAN topologies, right? Now the OVA file will be sent to you in the first week. So this week, sometime I will send you the OVA file. As I mentioned, just need to import it into the EVE-NG. Now, what is the requirement for the system for this? So unlike other courses, because this is SD-WAN, so you will see that there are some certain controllers who needs more resources. And then there are some end devices called the VHs. They also need some resources. So the recommended RAM or system memory for this is 32 gig. So if you have a system with 32 gig RAM, that will be ideal. But the minimum requirement is to have at least 12 to 6 gig RAM. That will also work. It might be slightly slower to boot the devices, but once they are set up, it will work smoothly, right? So up to 16 gig is also okay. Recommended is up to 32 gig to have all the systems. And if you, let's say, if you want to do the practice on your own and you want to add more VH devices, want to add more sites, it will be smooth if you have more RAM, right? So I see a question from you. How is the system performance with nested VMs in EVE-NG? Yeah, nested VMs also, it works perfectly fine. The only thing is that, see, anytime you have a nested VMs, there will be a little bit performance hit. But if you have the Intel VT enabled into the BIOS, then the nested VM should work pretty good. It should not be an issue. And initially, when you boot the devices, it might take slightly more time. And that's why I always say that when you boot the VM where vManage devices, at least give them 10 minutes to completely boot. And there is always a message, system is ready, and then you can start using them. But after the initial boot up, it doesn't take much time. And the system is pretty much smooth after that. So I have used it on 16 gig machines also. And currently I'm using it on my system where I have given 32 gig to it. So it works perfectly fine in both cases. Slight performance hit might be there, just a little bit slower in case of 16 gig, 12 to 16 gig part, right? And after importing OVA, make sure to adjust the RAM to the required value and set the first interface to NAT if not already done, so that you always get a proper IP address to use. Of course, this is something if you already know about VMware and you want to set it to a different one like VMware interface, you can definitely do that. But NAT is generally works perfectly fine. That's what I have noticed, right? That's what I've seen. So for example, if you see the diagram here on the right hand side, if you go to the virtual machine settings, the network adapter should be set to NAT and the RAM should be adjusted according to you, right? So when I send you the OVA, when you import it, it might take some default RAM value, 4 gig or 8 gig. Make sure to adjust it according to your requirement or your availability of the RAM, 16 to 32 gig, right? Hey, hi, Jose. Welcome to the class. So these are the tools that we will use for this. And now let's talk about the SD-WAN topics that we are going to cover. So this is like a more complete approach to cover all the important topics of SD-WAN. So we are going to start with the introduction. So in the introduction, we will talk what is SD-WAN and what are the use cases of SD-WAN and how it is different from traditional WAN, what are the important components of SD-WAN and how do they interconnect, so that we know all the nomenclature of SD-WAN, right? What are the different terms we use? What is the meaning of T-lock, OMP, or different controllers like vManage, vBond, vSmart? What is the role of VHs? How do they connect to the controllers? How do they connect to each other? How do we make sure that they are secure? How do we make sure that no ROC devices or no fake devices are connected to our SD-WAN infrastructure? So the basic introduction will make sure that you are familiar with all the terms which will be used throughout the rest of the course, right? So introduction is very important, that we will actually go through a little bit this week and also in more detail next week. So after the introduction, we will go through the different parts of SD-WAN in detail, like what is the SD-WAN control plane, how does the routing information gets exchanged between devices, and this is actually part where we will go through the OMP, overlay management protocol, which is created by Cisco for the Cisco's SD-WAN solution. So in this part, we will understand how OMP works, how does it connect between the VH devices and the vSmart, which is the controller for SD-WAN, and how we can actually see the impact of it. So this is where we will understand OMP in depth. And of course, once the routes are exchanged, then it comes to the main part where we exchange traffic and how the traffic gets exchanged between the SD-WAN devices and what components are used for that. So data plane part will be covered there. And then third part, we will start the practicals. So SD-WAN implementation from scratch using smart licensing. So there will be one lab where we will actually go through the implementation right from scratch. So let's say if you have completely blank topology and you want to spin up your own topology, add all the controllers, adding few VHs, connecting them, making sure that all the control plane sessions are coming up, making sure all the data plane connections are coming up. And for that, you will see that we need smart licensing from Cisco. So how we can do it using smart licensing, we will do step-by-step practical and make sure that we understand it and we are comfortable with it. So you will see that for the exam purpose, like if you are planning to go for the CCIE exam also, you don't need to do licensing, because in exam also the devices will be pre-set up. They will ask you more advanced questions, but it is always good to know how the licensing work, how the communication between controllers and the end devices work. So this will be a good practical to see that part, and also how to use the Cisco Smart Licensing, how to set up the account, and how to download the serial file, which will have all the serial numbers for the VHs. Because remember, we have controller devices and then we have the edge devices called the VH devices. These VH devices, we are going to use these are called the VH cloud devices, because we are using them as virtual machines into EVNG. So these are not hardware VHs. If you buy hardware VHs from Cisco, if you are running it in a real environment, in an enterprise environment, they will have their burned-in serial numbers, right? Every device has a serial number. But here we are running virtual devices, so they don't have serial numbers, and we need to generate their serial numbers. And that's where the smart licensing comes into the picture. So we will go through that as well. And then we will start getting into the details of configuration of SD-WAN devices. So when you think about SD-WAN devices, you may have implementation of 50 branches or 100 branches. Every branch is using at least 2 VHs for load balancing and fault tolerance purposes. So how do you configure so many devices? And how do you make sure that there is no scalability issue? So what SD-WAN allows you, you will see later when we go into the details of all the components, that you have a single pane of glass for management, and you can configure all the devices either using CLI right from a single location. We do it from the vManage, or you can also create something called device and feature templates, which are the GUI based configuration right from the vManage. So it becomes very easy to configure devices initially, and also to change any configuration in future on multiple devices at the same time, and with the least errors possible. So these are called the templates. You can configure templates on the vManage, and the configuration is then pushed to the devices via vSmart, right? vSmart is the controller. So you can, if you like CLI, if you like command line infrastructure, you can still configure all the CLI right into the vManage, and then it will be pushed to the devices. So these will be called the CLI templates, or you can use the GUI templates called the device and feature template. So we'll go through that. And then, of course, comes the important part, service VPN side routing using static routing, OSPF, and BGP. So if you have multiple branches, of course, you will have your SD-WAN fabric, where your controllers and VHs are connected to each other. But every branch who has some one or more VHS devices, they have their internal network also, right? Every branch will have some routers, switches. You might be running some internal routing protocol there, IGP protocol or BGP, static routing, OSPF or BGP. So how we can configure these protocols between the VH device in the branch and the internal routers or switches into the branch, and then how do we propagate that information using SD WAN protocol OMP to other VHs and other branches, right? So these are called the service side VPN. And anything which connects the SD WAN devices, that is called the transport VPN. So that is called VPN number 0. So don't worry, all these things also will be covered. Currently, I'm just mentioning what topics will be covered. So we'll get into the details, and of course, we'll do the practical of configuring these protocols into the branch side or service side as well, right? And then we'll come to the core part of SD-WAN, where we configure the policies. So one of the important aspect of SD-WAN is to control your network on from a single location. And by controlling, we means that creating policies and enforcing them on one or more locations. So we can create centralized control policies, and these policies can be pushed to the controller, which is vSmart. And this can actually impact your control plane, means your routing decisions, that which routes will end up where, and which connections will be allowed, which connections will not be allowed, which branches can communicate directly. Is it going to be a hub and spoke topology between branches, or is it going to be a full mesh or partially mesh? So all these things we can control by creating centralized control policies. Similarly, we can also configure centralized data policies, where we can control the impact of these policies on the data plane. So when the traffic is actually moving, that time we can take some actions, and we can decide all these things also centrally on the vManage. So everything you can manage from vManage, and that's why it is called the central management system, or vManage. And that's why these are called the centralized policies, control or data policies. But sometimes you also want to do some things directly on the VH without logging into the VH directly. So for those, we have the other policies also, right, which is called the localized policies. So one of the application of SD-WAN is application aware routing. This is very, very interesting concept. What happens in the traditional WAN networks is that your traditional routing protocols, they are only able to know about any kind of blackout situation. So if a link is working, it can be used into your network. If the link is down, it cannot be used into your network. So your routing protocols can only see up to that part, but they are not actually properly tuned for any kind of, or not even capable of sometimes, to find out any brownout situations. The brownout situation means that a link is still operating, but it's not operating optimally. It doesn't have all the parameters properly working for it. It has some delay, jitter, some packet loss, but the link is working, but it's having some issues, right? So in those cases, your traditional routing protocols are not able to catch it, or to stop using it, or use that particular link less comparing to other links. That is not possible easily in the traditional routing protocols. That's where SD-WAN shines, because it can actually create brownout policies called the application aware routing, where you can decide which link will be used for which certain application based on its current performance. How much delay is there on the link? How much jitter is there on the link? What is the round trip time on this particular link at this point? How many packets are being lost every 100 packets or 1000 packets? So we can see the packet loss percentage as well. And there might be some very, very important mission critical applications. You can set these criteria that this application need at least this much percent of bandwidth. It needs not more than this much percent of delay, jitter, or packet loss. And then accordingly, the link will be selected. One or more links will be selected to send up traffic for that application. And then for some miscellaneous application, some scavenger applications, not so important applications, you can force them to go through the links which are not operating at their 100%. So this is one of the biggest reason why would you want to use SD-WAN, because it's the intelligent WAN. It is actually taking different routes, not based on their static criteria like bandwidth or the link status up or down, but more of the brownout situations. What are the different parameters, bandwidth, delay, jitter, packet loss? Based on that, it can take its decisions, right? So very, very important thing, application aware routing. We will see the examples of those as well, and we'll do the lab as well for that. We will see the localized policies as well. So as I mentioned, that some configurations you might need to do on a particular VH for that particular branch. So these policies will directly be applied to a particular site or a VH. So these policies are called the localized policies. Again, these policies also you can configure on vManage, and they can be pushed to the certain VHs. So again, you don't need to log into individual VHs for anything. Everything you can control from a central location, right? So we will cover the localized policies as well. And of course, we will touch upon some of the topics like SD WAN security and QoS. So we will see some theoretical part of it as well for the Cisco CCNP level exam if you want to take that exam, and some of the practical aspect as well, like what are the different quality of service implementation we can do, what are the different security options do we have into SD-WAN. So we will touch on that as well. And high availability, scalability, and disaster recovery. So how we can make sure that our SD-WAN remains up, so the uptime is more, and how we can make it more scalable means how do we make it easier to keep on adding new devices without making much changes. And of course, in case of a failure, what would be the course of action in the case of disaster recovery. So some of these things also we will cover, right? So this is our basic idea. We might add or fine tune few things from this, but this is the core structure, right? This is the basic idea what we are going to cover into this course, right? Now let's talk about the topologies that we are going to use a little bit more. So in our course, we will have two topologies. First lab that we will do is the SD-WAN licensing. So we will use a separate topology for this. Because in this one, we will start from scratch. So we will add all the controllers and few VHs, and they will have absolutely no configuration. And we will start from scratch, and we will see how the licensing can be achieved. So again, if you're going for CCIE lab, you don't need to know this stuff, because they will have the setup or pre-provisioned devices into the exam, and they will ask you just more advanced questions like creating control policies or feature templates, and controlling the routing of the device or the data plane control. But it's a good idea to know how exactly licensing work, as I mentioned earlier, and it's a good idea to set it up also step by step. So we will go through the first lab also. First, SD-WAN licensing, basic lab to set up controllers and VHs, and the controller licensing and the VHs licensing. That's what we will cover into this lab. And the second lab, or labs I should say, are the configuration labs. So configuration labs, we will have multiple configuration labs for different topics. And for that, we will use the lab or the topology called Karotul SD-WAN, right? So in this one, we'll use the SD-WAN topology with multiple sites and various service VPNs. Means in this case, our licensing will already be there. The connection between the controllers and the end devices, VHs, will already be there. But now we want to make sure that the VHs can communicate to each other, and they have their own service side, branch side route networks, and we want to enable communication between branch to branch or site to site, and control all the aspect of it. So that's where we will use this Karotul SD-WAN lab, right? So this will be the service VPN side routing also will be covered in this. So if you remember from last side, I told you we will also cover static routing, OSPF or BGP in the branch side. So that configuration between the VHs and your internal routers, that will also be covered into this one. Inter-site routing and reachability will also be covered into this. And all the SD-WAN advanced topics that we had listed will be covered using this topology called Karotul SD-WAN. So we will have two topologies when I send you the OVA. One is the SD-WAN licensing lab, which will be just devices connected, but there will be no configuration if you want to practice licensing. And the second one is the Karotul SD-WAN, where the licenses are already set up. The basic connectivity is already there. But now we are just going to concentrate on advanced topics, right? So let me give you an example of this. Let me go to the OVA 138. So let me open that. So the username is admin and the password is EVE. So you see that when you open it first time, it will show you two topologies, Karotul SD-WAN and SD-WAN licensing. So SD-WAN licensing is what we will start with, but later all the advanced topics we will cover with the Karotul SD-WAN, right? So let's go to the SD-WAN licensing to show you that. Currently you can see it's blank, but when I send you the OVA, it will have the devices here, but without any configuration. So let me show you what will be the topology you will see. So when you right click and select the node, you go all the way down to the SD-WAN devices, and you can see we have Viptela, vBond, VH, vManage, and vSmart. These are the 4 types of devices we will be using. So vBond, vManage, and vSmart, these are the controller devices, and VH is the branch side end device. So why is it calling Viptela? Because Viptela is the company who created this SD-WAN concept, and Cisco actually took over, and Cisco purchased that company, and now Cisco uses Viptela as the SD-WAN solution. Cisco also has another SD-WAN solution called Meraki. Cisco also took over the Meraki organization, and it is now the Cisco's SD-WAN solution for the small or mid-sized companies. So for small or mid-sized implementations, we have Meraki SD-WAN, which is simpler, but not so scalable. And then for large scale implementations, we have Viptela SD-WAN, which is what we are going to cover into this particular course. This course does not cover Meraki SD-WAN. So let's add these devices. So vBond. So when you add a device, for example, when I send you the OVA, you will already have these devices added. But in case if you also create a topology and you want to add it, you will see that the RAM requirement is shown as 1 gig for vBond. So you can keep it 1 gig. That is okay for vBond. Same thing for vSmart. But for vManage, you will see, because vManage is a single pane of glass, this is where all the GUI configuration will go. You see that by default, it takes 16 gig of RAM for this. So if you have provided 32 gig to this EVNG, then you can leave it at 16 gig. But let's say if you are using overall 12 to 16 gig, then I would suggest you to change it to 8 or 10 gig from here, right? So you can change it to 8,000 or 10,000 accordingly. But in my case, this is okay. Let's add vSmart. This is the third controller. vSmart is 2 gig. Again, let's keep it that. And you can keep them here. These are the controllers. Excuse me. And then we can add the VHS. So for VHS, you can add like a couple of VHS to practice. So you can include Viptela VH. Number of nodes you can change to 2. And you can see VHS are also using 1 gig RAM each. So that is fine. So you can see VHS are here. Let me rename it to VH1 and 2. VH1 and VH2. And because we are just going to concentrate on licensing, not the topology itself, I'm just going to simply connect them all together using a simple Cisco switch. So Cisco IOL switch L2 image. L2 image here selected. And let's just change the diagram to a switch. For this one, you can change the RAM to 256 MB. That will be sufficient, because this is a simple switch we are using just for connectivity between the devices, right? So then we enable the connectivity between them. So from vBond side, you will see that we have ETH0 and Gigabit Ethernet 0/0. So make sure that from vBond side, we use Gigabit Ethernet 0/0, not the ETH0, because you will notice one thing later, is that the vBond is using the same image as VH. So in virtualization, the vBond is not a different device. It's just one of the VH, but we will use it as a vBond. That's why it is going to use the Gigabit Ethernet port. But for vManager and vSmart, it is going to be the ETH port that you will connect. So from vManager, ETH0 is okay. vSmart also, ETH0 is okay, right? Only the vBond will be Gigabit Ethernet 00, because that is same as VHS, who will also use the Gigabit Ethernet ports. So we connect from VH Gigabit Ethernet 00, and from VH1 it's done. From VH2 also we'll do the same. Okay, I need to increase the number of ports on switch. we have only 4 ports because we are using one Ethernet port group in switch. So let's change it to 2 Ethernet port groups. So we have 8 ports. And now let's connect it. So again, from VH side, gigabit Ethernet 00. So what we need to understand is that from the VBond and VHS, we need to use the gigabit Ethernet port, gig E0/0. From vManager and vSmart, Ethernet 0 is sufficient, right? Again, when you get the OVA from me, even into this licensing lab, you will have this setup already there. The configuration will not be there. We will start from scratch, but this setup will already be there. But I'm just showing you that so that you know that how the connectivity is done. Also remember that we will be having a graphical user interface connection or GUI connection to the vManager. So for that, we need a out-of-band connection to vManager also. So what we can do is we can right-click and add a network here. And we are going to add the type management cloud 0. Management cloud 0. That is going to allow you to connect to your vManager using the same network you are using to connect to your EVNG. Like I'm using 192.168.79 network to connect to my EVNG. So by using this management cloud 0, I will have an IP address into the same network on vManager, and I will be able to access it directly from my browser here, from my computer. I can directly use the browser, right? So that is possible. Excuse me. So we just connect it to the second available port on vManager, which is ETH1, sorry. So that's it. That's your physical topology that you will need to start configuring device and start configuring licensing and all, right? So this is something we will do next week. I just wanted to show you that this is the topology that we will be using. And let me close this lab. Let me show you the Karotul SD WAN lab also, which is going to be used, or Karotul SD WAN topology, which is going to be used for advanced labs. So you can see in this one, we have the setup where we have different sites. As you can see, we have site 1, which hosts all the controllers, vSmart, vManager, vBond. And then we have some routing infrastructure. And then we have different sites. You can see on the right-hand side, site 100, site 200, and site 300. So these are like 3 different branches. And every branch have one VH device. You can see VH1, VH2, VH3 connecting to some internal router of that branch, R1, R2, R3, right? And then every VH has 2 internet connection. One is the public internet, which you can see with the keyword INET. And another connection is the private internet connection or private connection, which is called MPLS. So you can see we have MPLS connection also. So from every VH, we have 2 links going out, which is simulating 2 different WAN connections. One is the internet connection, normal internet, and one is the private MPLS connection. You can see that internet connection has public IP address 201, 202, 203, and MPLS has private IP addressing 10.11, 10.12, 10.13, right? And all the excuse me, all the controllers, they are connected to the internet using the 50.0.0 network. So 50.0.0.2.3.4 IP addresses, and the gateway is 50.0.0.1. So we will be using this topology for most of the advanced topics. So in this topology, you will see when you spin it up, when you boot it up, that the licensing is already done. The VHS are already showing up into vManager GUI. And now we are just configuring the advanced stuff, right? Like templates and policies and security and all, QoS and all these things, right? So that's what we will cover here. So that's what we will get into the OVA. Let me close this and let's get back to right. So topologies we already talked about, right? All right. So now consideration for EVNG lab. So whenever you boot up the EVNG lab, for example, you are doing any advanced topic and you want to boot up that Karotul SD WAN lab, remember the order of your starting devices should be this. Now, unlike normal topologies, don't just start all the devices at the same time, especially if you have lower capacity for the RAM. It's better to start the devices one by one. Also, they try to capture the whole processor processing power you have into EVNG. So it's better to start them one by one. Otherwise, it might take very long time to boot up everything, right? So the idea would be to start the controllers first, one by one, in following order. So start the vManage first. Start and wait at least for 10 minutes before starting other devices. It's a good idea. And look for the message system is ready on the CLI so that you know that vManage is already started. And once that is done, you know that vManage is already up and running. Then start vBond, and again wait until the system is ready message appears before starting next device, and then start the vSmart after that. So this way you will not overwhelm your CPU and RAM. You will actually go step by step, especially the CPU, because they try to use the complete CPU power of your device. Maybe it's one of the virtual machine things, but that's what happens. Once all the controllers are started, then you start VHS one by one. Again, same thing, wait until the system is ready message appears before starting the next device. After that, start any non-SD WAN devices like routers and switches. And make sure you can ping between controllers and to any VHS. So if your pre-configuration is already there, then make sure you can ping between these devices, especially like if you are doing the licensing one where they are directly connected using a single switch, they should be able to connect. And even if you're using the Karotul SD-WAN topology, the iNet router and the MPLS router are pre-configured with proper routing. So if your initial configuration is there on your controllers and VHS, they should be able to ping end-to-end. So that's the consideration for EVNG lab every time. Every time you do any lab, and if you haven't started the devices, make sure you start them in this manner. Give it some time, and then start doing the lab. So it will be very fast, and it will not actually hang for a long time, right? All right. So the next thing is what kind of certifications you can actually attempt after completing this course. So what this course is going to help you Cisco certification wise. So this course is actually pretty much very nearly aligned to Cisco CCNP Enterprise SD WAN Solution Certificate, which is the ENS TWS certificate 300-415. So most of the topics that you will learn here, they align to this particular certification. And after maybe doing a little bit more theory practice and multiple choice questions practice, you should be able to pass this exam after completing this course. Right? So this is what nearly it is aligned to. But also some part of CCNP Encore exam, you can also cover, complete after completing this course. So of course, Encore has a lot of more other things as well, different things as well, not just SD-WAN information, but there are some architectural questions in Encore which you will be able to answer after this. Right. So in Encore also it can help you. And of course, if you are going for the CCIE lab, CCIE Enterprise Infrastructure Lab, this course will definitely help you. It will cover everything and a little bit more than what you need for the CCIE Enterprise Infrastructure Lab. Right. So the only thing is that we don't cover any multi-protocol labs here in this. So if you are also our student for 0 to lab, you will see that we also go through the multi-protocol labs where we go through very similar to exam-like situations. So you will see a better implementation there for CCI exam, right? So these are the certifications that you can attempt after this. So that's it. Let's get started. And from next week onward, we will start. So this week, look out for my email where I will go through I'll send you the OVA and also send you any necessary licensing files that you will need. And next week we will start from the first detailed topic, right? Thanks a lot.